Alright, now I want to cover a little more about the conditional, and specifically the converse of the conditional and the inverse of the conditional. If our conditional is P implies Q, then by definition the converse of that is Q implies P. Just flip it around. And the inverse of P implies Q is not P implies not Q. So the converse is kind of backwards. The inverse, you negate the antecedent and the consequent. Negate each one of them. And now let's put this into practice. If this is our statement here in the form of P implies Q. If the streets are not dangerous, then there is an ice storm. So what would our P be in this case? I'll just mark it off this way. If the streets are not dangerous, all the way up to the then, that is going to be our P in this case. Did I make my P correct? Yes, I did. Then there is an ice storm. That is going to be our Q. Right here. So that is Q. And we want to know if this is P implies Q, what is the converse of the statement? So P is the streets are not, I should have probably put this over here, not the if. The streets are not dangerous. And the Q is there is an ice storm. So the converse would be just the flipped around version of that. In other words, if there is an ice storm, then the streets are not dangerous. So that's the converse of that. We flip it around, Q comes first, then P. The inverse of that, we negate both of them. So the way we would read this inverse is, if the streets, see it says the streets are not dangerous, so the negation of that would be, if the streets are dangerous, then there is not an ice storm. So that would be the inverse. We negate both statements. So the key on problems like this is really just identify your P and Q. And once you do that, they're easy to manipulate because you know how to get from here to here to here. And once you know your P and Q, you can, by following this format, you can flip them around any way you need to.